Good day, everyone. Welcome to Teacher Fina Lesson in Math. Our lesson today is all about the prime factorization. The objectives of lesson: determine the prime factorization of the number. Applies two methods of getting prime factorization of the number. Any composite number can be expressed as a product of prime factors. This can be done through the process called prime factorization. To find the prime factorization of a number, express the number as a product of two natural numbers. Then write every composite factor as a product of primes. There are two methods to do prime factorization. The first one is the factor tree method, and the second one is the continuous division method, or also called as the repeated division. Factor tree method. It is a diagram used to determine the prime factors of a natural number greater than 1. Let's start with this example. We have 16. We're going to write two factors under each number. So the factor of 16 can be 4 times 4. 4 are composite numbers we're going to express. 4 the factors are 2 times 2, and 4 the factors are 2 times 2. 2 is prime, so we're going to stop when all the factors are prime. So the prime factorization of 16 is 2 times 2 times 2 times 2. It can be also in exponential form, 2 to the 4th power. Let's have another possibility. We have 16. The factors can be 2 times 8. 2 is a prime and 8 is a composite number. Let us express 8. We have 8. 4 times 2. 4 is still a composite number. So 4 we have 2 times 2. 2 is a prime number. So we're going to stop when all the factors are prime. So the prime factorization of 16, we have 2 times 2 times 2 times 2. Let's show the prime factorization of 36 using the factor tree method. We have 36. 4 times 9. 4 is a composite number. Let's express. We have 2 times 2. 9 is a composite number. The factor are 3 times 3. So we have 2 and 3 are prime numbers. So the factor form of 36 is 2 times 2 times 3 times 3. And the exponential form is 2 squared times 3 squared. We can also use this one. We have 3 times 12. 3 is a prime number and 12 is a composite number. So 12, that is 3 times 4. 3 is a prime number and 4 is a composite number. So 4, we have 2 times 2. 3 and 2 are prime numbers. So the factor form of 36 is 2 times 2 times 3 times 3. The exponential form is 2 squared times 3 squared. Another, we have 2 times 18. 2 is a prime number and 18 is a composite number. 18 can be 3 times 6. 3 is a prime number and 6 is a composite number. 6, we have 2 times 3. So 2 and 3 are prime numbers. We have the factor form is 2 times 2 times 3 times 3, or it can be 2 squared times 3 squared. The given example illustrates that no matter what factorization of a number we begin with, the prime factor will be obtained. Let's proceed to the second method. We have the continuous division. Continuous division is we're going to divide the number with the next prime number and repeat this process until the number is completely factored with all the factors as prime numbers. Let's try to factor 64. We follow the format. We have divisor, dividend, and the quotient. That is the format in continuous division method. Example number 1, we have 64. We're going to divide 64 with the smallest prime number, which is 2. The 64 divided by 2 is 32. Divide with the smallest prime number, which is 2. 32 divided by 2, we have 16. Divide with 2 again, we have 16 divided by 2 is 8. 8 divided by 2, that is 4. And 4 divided by 2 is 2. The final quotient is already a prime number, so we're going to stop. Therefore, the prime factorization of 64 is 2 times 2 times 2 times 2 times 2 times 2. That is the factor form. It can also be the exponential form, 2 to the 6th power. Example number 2, we have 84. We're going to find the prime factorization of 84. Divide with the smallest prime number, that is 2. 84 divided by 2 is 42. 42 divided by 2, that is 21. So we're going to divide it with the next smallest prime number, which is 3. So 21 divided by 3 is 7. 7 is a prime number, so we're going to stop. So the factor form of 84 is 2 times 2 times 3 times 7. It can be also 2 squared times 3 times 7. Let's try to answer this one. We're going to complete the factor 3. 42, so the missing number is 7 times 6. The factor of 6, we have 2 times 3. So the prime factorization of 42 is 7 times 2 times 3. Another example, we're going to complete the factor 3. We have 24. Write the missing number. So 2 times 12. The factor of 12, we have 2 times 6. The factors of 6, we have 2 times 3. So the prime factorization of 24 is 2 times 2 times 2 times 3. Complete the repeated division. We have 32. Divide with the smallest prime number, 32 divided by 2, that is 16. 16 divided by 2, that is 8. 8 divided by 2, that is 4. 4 divided by 2 is 2. So we're going to stop because 2 is a prime number. So the prime factorization of 32 is 2 times 2 times 2 times 2 times 2. Another one, we have 54. Complete the repeated division. And so we're going to divide 54 with the smallest prime number, which is 2. 54 divided by 2 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. So we're going to stop because 3 is a prime number. So the prime factorization of 54 is 2 times 3 times 3 times 3, or it can be 2 times 3 cubed. So that is all about the prime factorization of the number. Remember, to find the prime factorization of a number, using the factor tree method, we follow these steps. Express the composite number as a product of any two factors. If one or both factors are not prime, factor each again. Repeat the process until the prime factors are obtained. To find the prime factorization of a composite number using the composition method or the continuous division, we follow the steps. We have divide the composite number by the least prime number that will exactly divide the given number. Repeat the process until the final quotient is a prime number. Write the original number as a product of its prime factors. That's all for today. I hope you learned something. See you again next time. Bye!